So here's an application of completing a square. So we're going to find like the maximum or minimum in word problems. Okay, example 1. A model rocket is launched straight upwards with initial velocity of 200 meters per second. The height of the rocket, h, in meters, can be modeled by this equation. Okay, so these types of questions are a little easier because they already give us the equation. Okay, where t is the elapsed time in seconds, what is the maximum height the rocket reaches? So as soon as it asks us for the maximum, we're looking for the vertex. Okay, and then when does it reach this height? So we're looking for like the axis of symmetry. So I'm going to go ahead and do this. I mean, when I look at this, I can simply factor it, find the equation of axis, and sub it back in. But I'm going to use completing the square this time. Okay, so I'm going to have h equals, we're going to float that -5, t squared minus, I'm going to go 200 divided by -5, I get -40. T. Okay, at the side of our paper, let's go 40 divided by 2. I get 20, and then square it, I get 400. So inside of this bracket, we're going to go ahead and put t squared minus 40t plus 400 minus 400. Okay, this -400 comes out, we multiply it by -5. So I'm left with the trinomial t squared minus 40t plus 400. And then -400 times -5, I get 2,000. So the 2,000 will come outside of the bracket. Okay, and all we have to do, I mean, there was nothing over here. It was kind of like a +0. So we have nothing to add onto the 2,000. But all we have to do is factor this trinomial, and I get t minus 20 squared plus 2,000. Okay, that gives us a vertex of 20, 2,000. Okay, and then therefore max height is 2,000 meters, and then this occurs at time equals 20 seconds. Example 2, find the dimensions of a rectangle that has a perimeter of 40 and the largest possible area. Okay, so our biggest thing is like the largest possible area. We're looking for like a maximum, therefore we're looking for the vertex. Okay, so here's the discrepancy. It asks for the area, but it gives us the perimeter. So we actually have to create two different equations. So we know that the area is always length times width, right? And we know that the perimeter is always 2 length plus 2 width for a rectangle. So what we actually have to do is we have to work with what they give us. So the perimeter is 40, so I'm going to go ahead and sub in 40 equals 2L plus 2W. What I'm going to do is I'm going to just bring over the 2L. I'll make an L like that, curly L, so we can see the difference. And I'm going to actually isolate for this W. It's kind of like a substitution here, where I'm isolating for one variable in one equation, and then what we're going to do is we're going to sub it into the other equation. Okay, so we find that W equals 20 minus L. So we can go ahead and sub that into the area equation here. So we have L and then 20 minus L. Okay, this, looking at it, I mean, personally, I would factor this, find the axis of symmetry, and again, sub it in, find the vertex, but we're going to use completing the square just because that's the lesson that we're on. So I get 20L minus L squared. I'm just going to rearrange this. So I get -L squared plus 20L. Okay, and then just going back a little bit, we use L and W, so we're going to go let L represent the length, and we're going to go let W represent the width. And this is of the rectangle. Okay, so from here, we have an equation right here. We're going to go ahead and complete the square. So I'm going to go ahead and factor out that -1, and we're left with L squared minus 20L in the bracket. Nothing's outside the brackets, like plus 0. So let's take this 20 to the side of our paper, divide it by 2, and we get 10, and then square it, and we get 100. So we're going to go ahead in this bracket, and we're going to add 100, and then subtract 100. Kind of cut that up a little bit. Okay, so we have a equals negative L squared minus 20L plus 100. And we have to factor this, and then we're going to move the negative 100 out, but because we factored out originally the negative 1, that's going to change into positive 100. So we get A equals negative L minus 10 squared plus 100. Okay, that gives us the vertex of 10, 100. Okay, and because this was our original equation here, we're dealing with L and A. So this is actually our length, this is actually our area. Okay, so we can say length is 10 centimeters. Okay, the area is going to be 100 centimeters squared. And then we can solve for the width right here. We would do like the 20 minus the 10, which is again 10 centimeters. So those are the dimensions of the rectangle with the perimeter 40 centimeters that has the largest possible area. Okay, example 3, a rectangle field will be fenced on all 4 sides. Okay, so we have this rectangle field right here. There will also be a line of fence across the field parallel to the shorter side, splitting the rectangle into 2 parts. Okay, and we can assume that they're equal for this question. Okay, so if we have, let's call this x, so we would have 3 x's here, and then we would have 2 y's here. Okay, if 900 meters of fence is available, so what they're giving us is the perimeter. Okay, what dimensions of the field will produce the maximum area? So we're reading maximum, we're thinking about vertex. Okay, so again, we have to start with 2 different equations. So we can always start with A equals length times width. And then usually the perimeter is 2L, or like 2 times the width plus 2 times the length. But the perimeter is going to be a little bit different this time because basically what we're going to do is just add all of these dimensions up. So we would have 2 y's, and we'd actually have 3 x's this time because part of our like perimeter is to split this rectangle in half. Okay, and then we can always go let x represent the length, or the width, I should say. Usually we do the width is the shorter side, but it really actually doesn't matter. They're interchangeable. And y represents the length, which is fine. Either way, you can use whatever variables you want. And so with this perimeter, the perimeter is 900, so let's go ahead and sub in the 900. Okay, so I'm going to isolate for y, and the reason why I want to, no, let me isolate, I'm going to isolate for x. Okay, and the reason why I want to isolate for x is because if I have a 3 on this side and I divide out a 3, I can actually go 900 divided by 3. I guess I could have divided it by 2 as well, but that's okay. Okay, so we get 300 minus 2 over 3y, right? Because this 3 is the denominator and it has to go on both numbers, and that's going to be our x. So this is our expression for x. Now let's sub it in here. Let's change colors. Okay, area is, well, instead of L times W, let's go X times Y. Let's keep it consistent. Okay, so the area is 300 minus 2 over 3y times x. And let's go ahead and distribute in that x. So we get 300x minus 2 over 3. Oh, sorry, this was the y. Right, y squared. or we subbed in for x. Okay, I'm going to just put this in order. Negative 2 over 3 y squared plus 300 y. Now, we have the equation for the area in terms of y. So let's go ahead and complete the square. So if we factor out this negative 2 over 3, we're left with y squared. And then 300 divided by 2 over 3, we get 450. We get minus 450y. Okay, take 450 to the side of your paper, divide by 2, and then square it. So I get 225 squared. I get 5625. Okay, so inside of this bracket, we might have to move to a new page. Inside of this bracket, what we're going to do is we're going to go y squared minus 450 plus 5625 minus 5625. Oh, and then that's it. Okay, so let's copy this trinomial, y squared minus 450y plus 5625. Okay, and then we're going to pull this negative 50,625 out of the brackets, and we're going to multiply it by that negative 2 over 3. So when we pull this out and multiply it by the negative 2 over 3, we get positive 33,750. Okay, I do want to put this on the same page, but I might have to. Okay, this was easier. So we're going to go ahead and factor this trinomial, negative 2 over 3, and then it's going to be y minus 225 squared, and then plus 33,750. Okay, so we get a vertex of 225, comma, 33,750. So even if we look in this row right here, what we're dealing with is the 225 would be the y, and then the 33,750 would be the a. Okay, so therefore, if we go back to what we're actually dealing with, y is the length and the x's are the widths, right? So we would have a length of 225. We would have an area, so the maximum area of 33,750. That's meters squared. And then we would have a width. If you remember, it was the 300 minus 2 over 3y. So 300 minus 2 over 3, 225. And I get 150. Okay, so we have the length and the width, which is the dimensions there, and then we have the area. Okay, the city transit system carries this many bus riders per day, and then this is the fare. So 24,800, and the fare is $1.85. Okay, the city hopes to reduce car pollution by getting more people to ride the bus while maximizing the transit system's revenue at the same time. Okay, a survey indicates that the number of riders will increase by 800 for every 5-cent decrease in fare. Okay, so we have increase, which is like a plus 800, and then we have minus 5 cents. What fare will produce the greatest revenue? How many tickets will they have to sell in order to produce this revenue? And what's the maximum revenue, okay, that the city transit system can generate? So we have this revenue equation that we're going to deal with, and we're going to deal with it this year and next year. So we have to group the number of tickets sold and then the price as well. Okay, and then X is going to represent the number of price increases and decreases. So what we're dealing with for the ticket sold would be 24,800. And then every time they reduce the fare, 800 more people are going to ride the bus. So plus 800x. Okay, and now what about the price? Well, it was originally $1.85, but then they're going to reduce it by 0.05 x number of times. So what our equation is actually going to be is R equals 24,800 plus 800x, and then 1.85 minus 0.05x. Okay, because we're under the completing the square unit, I'm going to go ahead and I'm going to expand this and then take it on to the next page, and then we'll complete the square with it. Okay, so what's 24,800 times $1.85? I get 45,880. Okay, 24,000 times 0.05, so minus 1240x. Then we have 800 times $1.85, and I get plus 1480x. And then 800 times 0.05, and I get negative 40x squared. So let's go ahead and put this in order. I'm going to do like negative 40x squared, and then these two terms in the middle add up to 240x, and then we're going to add 45,880. So let's go ahead and take this equation on the next page, and let's complete the square to find the vertex. So let's go ahead and complete the square, okay? So we're going to bracket off the first two terms. We're going to factor out that negative 40. Okay, we're left with x squared minus 6x, and then on the other side of the bracket, 45,880. Okay, so what we're going to do is we are going to take this 6, take it to the side of our paper, divide by 2, and then square it. So we get 3 squared, which is 9. Okay, so we get negative 40, and then we have x squared minus 6x plus 9 minus 9. Okay, and we'll keep that 45,880 outside the bracket. When we bring out this negative 9, we want to multiply it by that negative 40 because it's inside the bracket, now it's going out. So what we're going to have is negative 40, x squared minus 6x plus 9, which is our trinomial. And then we're going to have plus 45,880. And then when we multiply negative 9 times negative 40, we get plus 360. Okay, so let's go ahead and factor this trinomial inside of the bracket, and we get x minus 3 squared. And when we add these two numbers here, 45,880 plus 360, we get 46,240. So therefore, our vertex is 3, 46,240. Okay, and what this means is x is the amount of price increases. So therefore, 3 price increases will maximize revenue. Okay, so if we actually take a look at the price decreases, it was originally 185, and then we're going to subtract 15 cents. So the actual price itself is going to be $1.70, and then the number of writers. So if we take a look, originally we had 24,800, And then for every price decrease, there's going to be 800 more riders. So that's going to add 2,400 riders. So if we add those two, so 24,800 plus the 2,400, we're going to get 27,200. Okay, so 3 price decreases will maximize revenue with $1.70 fare, FARE, and 27,200 riders.